Okay, so in this video, I'm going to show you how to calculate what the equilibrium is going to be. And the equilibrium is going to be something like this, right? It's going to be some vector that we're going to have to drag in there. That's not it, so we'll figure it out, right? Okay, now our first vector, I'll call this guy vector 1, or I'll call it A. Okay, I'll call this guy B. Okay, A is displayed right here. You can see that I've clicked on that vector, and it tells us that its magnitude is, let's see, let's make a nice table here. Come on, man. Okay, A, its magnitude, and then the angle. I know that this angle is 135. Now, what they're telling me is that this angle right here is 135, which means that, of course, this angle right here is 45 degrees. Okay, so the magnitude of A is the thing that's in the table right there. So that's 9.9, whatever these units are, right? And then the angle is 45 degrees to the left of the x-axis, right? Okay. And what we want to do is figure out what the x component of this thing is and the y component, right? And then we're going to add up b, and then the equilibrium, this guy is going to be such that when we add all these things up, right, the third vector, right, is going to be such that when we add them all up, we'll get 0 here and 0 there. Okay, so let's figure out what b is again. Okay, so b is, the other vector is 15.8 at 18.4 degrees. So this angle here is 18.4, and this is 15.8. Okay, so this guy is 15.8, and it's at 18.4 degrees as marked there. And this 45 degrees is that one right there. Okay, so now we're going to just figure out what our x's and y's are. Okay, so this x component and the y component, by the way, are the same, right? So I'm going to go 9.9, and I'm going to find this component here is going to be, it's going to be negative, and it's going to be 9.9 cos, or sorry, sine of 45. Not that it matters. Okay, I'll make sure your calculator, by the way, is in degrees. Mine recently was in radians, so, but I'm checking the mode, and I'm good. Okay, so 9.9, and then I'm going to do sine of 45, and I get 7.000, right? So I'm going to say negative 7. And the reason it's negative is, of course, it's to the left. And then my y component will be positive. I'm sure that's going to be positive 7, but, you know, let's pretend like we don't know that, right? It's a 45-degree angle, right? So 9.9 cos 45. Oh my gosh, that's exactly 70. So this is positive 7, like 0, 0, 0, and whatever these units are, right? So that's the components of this one. Let's figure out these components here. Okay, so this side is going to be 15.8 sine 18.4. Sine 18.4. And that's 4.987, and that's in the y direction. That's positive, right? Okay, so that's my positive value there. And then let's figure out the x is going to be bigger, right? That's going to be 15.8 cos 18.4. And that's 14.99. 992 or something like that, right? Okay, now the question is, what do we add to this to get 0? Well, what I'm going to do is just add these guys together, right? Okay, so I'm going to get the negative 7, that guy, plus the number I just got. And if I add those together, it's 7.99. So this is going to be negative 7.992 roughly, right? Okay, and then what do I have to add to this to be 0? Well, if I add those together, I get, hold on here, I have to use the up arrow. That guy plus this guy. If I add them together, I get 11.987. So this must be negative 11.987. Okay. So now we just have to draw a picture of this vector, right? This vector is going to go back 7.992, and it's going to go down 11.987. And what we have to do is figure out the angle and the magnitude. Okay, it gets a little bit tricky, but we can do this, right? So the magnitude is equal to, hold on here. It's going to be the square root of 7.992 squared plus 11.987 squared. So I'm going to grab that guy, boom, squared plus boom, squared. And I'm getting 14.41. Okay, 14.41 is my magnitude, right? Whatever these units are, right? So 14.41. That's a 4. All right, and then this angle here is going to be tan minus 1. Find the inverse tangent of 11.987 over 7.992. So let's figure that out. And then this gets a little tricky, how to figure out that angle, okay? But I'll show you. There's a way to do this. Okay. So inverse tan of that guy divided by this guy is 56.3 degrees. Now, when you get into the simulation, you draw that other vector in there, it's going to give you a negative angle here, and that negative angle is this angle right here. You can picture this, right? It's going to be negative whatever this is, right? Well, to here would be 90 degrees, right? So this is just 90. No, this is going to be 180 minus 56.3 degrees. Okay, so that'll be what this angle is here. Okay, so if I went all the way to here, that'd be 180. But I'm 56.3 degrees short of 180, and that's what I'm doing here. Okay, so you got to be clever about it when you go in there and try to draw that next vector, and you'll see, I'll show you that in a second here. Okay, you're going to have to use the correct angle. So 180 minus 56.3, this angle right here is going to be, theta is going to be negative 123.7 degrees. Okay, so what we're going to have to do is draw some guy in here. Negative 123. It's going to be like something like this, right? And this angle here is going to be negative 123.7. This guy's going to be 14.4. And let's see, okay? Are you guys ready? Are you ready for this? I'm just going to go into it. Let's see if it works. Okay, so we go in here. And I'm going to grab this guy, put it there, okay? And I know that I want this to be 14.4 long and negative 123. Is that it? That's it right there. Look at that. So look at this. This is 14.4, just like we predicted, right? Or what we calculated, right? And then this is negative 123.7, which is just exactly what we got. Okay, you ready for this? Drum roll, please. Okay, brrr, here it comes. Are you ready? Here it is. Boom. Now, if you look at this, see, there's nothing there, right? I'll show you if we get it wrong. It's like, whoa, I didn't get it right. But if you get it right, there it is. Take a picture of that once you get it. Take a picture of the components and all that work you did, and then take a picture of this and then just upload, or actually just email them to me. I'm not going to put an assignment on the classroom, because when I do that, everybody thinks they have to turn it in, but a lot of people have already turned this in, okay? So just email this to me, a picture of this successful 3 vectors that add to 0, right? I'm going to see this, right? Okay, and then also your components that you got, okay, showing that the answer will be there, okay?